Hey everybody, so we're going to be talking about our next two postulates and theorems. We've got angle side angle and angle side. So the first one that we're going to start off with is angle side angle. And that's if two angles and the included side, this is super important right here, of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. And I'm going to do the same thing we did yesterday. I'm going to find the first alphabetical angle on my first triangle. And I found angle A. And this is on a 1 angle congruency mark. And I'm going to go clockwise. And I'm going to find its corresponding part on triangle XYZ. I'm going to circle X, angle X. And it's at angle 1. We're going to go to angle 2. Sorry about that, guys. All right, so, and then we go from none back to 1. So that way you have an order of what the letters are working with. All right, and as we do that, we're going to get our angle, which is angle A, and angle X are congruent. Then the side in the middle, it's sandwiched in between those two angles. That's side AB and XY. And lastly, we've got our second set of angles, which is angle B and angle Y, and those are congruent. And because you've got an angle, side, angle, you can then say that triangle ABC is congruent to triangle XYZ. And notice we're keeping it with our corresponding parts right here. They have to line up and they have to match. All right, now we're going to go ahead and do angle side theorem. Something similar, but this time that side is not included in the middle. In fact, it's a non-included side of one triangle. It's the one outside. It's kind of looking in from outside. And if you've got two angles in a non-included side of one triangle, congruent to two angles in a non-included side, a corresponding non-included side, by the way, of another triangle, then the two triangles are congruent. So same thing like we did last time. I'm going to go from 1 to none to 2, back to 1, 1 to none to 2, back to 1. All right, so as we start, I see angle 1, or angle A, is congruent to angle X. As we keep going, it doesn't work when we're going clockwise in this situation. But when we go counterclockwise, we do get a angle C is congruent to angle Z. And that's okay. If you need to do that, that's fine. But that means we need to keep going counterclockwise now. We can't use our clockwise. We can use it to write our congruency statement, but that's it. And so then we get line segment BC is congruent to line segment YZ. And they are corresponding parts, and we know that. All right, and because we've got our angle side, we can say that triangle ABC still working, and triangle XYZ are congruent. Now what we're going to do is we're going to figure out if we would use angle side angle or angle side to prove these triangles congruent. Again, if there's not enough information to prove them by these postulates or theorems, just write not enough information. It's okay. All right, so I'm going to go 1. I've got my 2 here and my 1 here, which means we've got an angle side, angle side. All right, for number 2, we've got our 2 angles here. And we're like, well, now what? But remember that reflexive property. This line, that same line, is congruent to itself, which means it's going to be angle side angle. All right, number 3, they've given us one angle congruency, a side that's congruent. We really want these two angles to be congruent, and we can say that because they're vertical angles. And because they're vertical angles, they're going to be congruent. You can say it's going to be an angle side angle. Number 4, remember this is the same side, so it's going to be that reflexive property. And we go from angle, angle, side. Angle, angle, side. And it's okay that you're going from 2 to 1 to 1. That's okay. All right. Okay, so we've got an angle. Corresponding side would be right next to that angle, but that's not what we have here. And even if we know that this side is congruent, something funny is going on. This triangle is trying to go for angle, angle, side, and this one's trying to go for angle, side, angle. Or sorry, side, angle, side. And we're not doing either of those together. No, there's not enough information. All right, now let's try number 6. Hopefully it's better than number 5. All right, so we've got an angle, corresponding angles. This side in the middle is congruent since using the reflexive property. And then our last 2 corresponding angles, totally good. All right, now we're going to see which of the 3 of each of these is going to be congruent by only angle, side, angle. So I'm going to go and draw my circles first. I'm going to go to none, to 1, to 2, none, 1, to 2, none, 1, to 2. All right, so I've got angle, side, angle as I'm going in my circle. And then as I'm going in this circle, angle, side, angle. So far we've got triangle SQR is going to be congruent to triangle VTU. Let's try this last one. We started at none to 1. Oh, there should be a side length here, but it's actually here. This one's not by angle, side, angle. Doesn't work. All right. This next one, same thing. None to 1 to 2. None to 1 to 2. None to 1 to 2. So I'm going to start with triangle ABC. None to 1, angle, side angle. All right, let's do DEF. None to 1 to angle, angle, side. So that one's not going to work. All right, let's do this one. Okay, none to 1, angle, side, angle. They're corresponding. So we can write our congruency statement of triangle BAC is congruent to triangle KJL. All right, let's try this last one. And you're going to see that 90-degree angle and you're freaking out. It's still an angle. And all right angles are congruent to each other. So don't forget that. All right, so I'm going to go none to 1 to right. None to 1 to right. None to 1 to right. All right, so none to 1 to right is an angle, side, angle. None to 1 to right, angle, side, angle. Oh my. None to 1 to right, angle, side, angle. It's all 3 of them. All right, now we're going to do our favorite part, and we're going to prove it. I know. You're already not excited. Don't worry, we got this. So first things first, we're going to use what's been given to us. And I have an error here, so I want you to fix this. And it should say congruent right here. BD is congruent to AC. That's what was given to us. All right? But because, oops, sorry, that's the opposite of what I want you to do. I want you to change it in your given up there. So right here is where it should say that it's perpendicular. Now, what's going to end up happening is that we are going to use that statement to help our reasons. All right, the first one is that we're going to use the definition of perpendicular. All right, and the definition of perpendicular tells us that angles BDA is going to equal 90 degrees, and angles BDC is also going to equal 90 degrees. And that's just the definition of perpendicular, because we know that BD is perpendicular to AC. All right, next they tell us that angle ADB is congruent to CDB. So ADB is congruent to CDB. Well, yeah, if they're both 90 degrees, then they're both right angles. And that means they're both going to be congruent. Now, we've been working on this first given reason. Let's try this next one. BD is bisecting ABC, meaning it's splitting this entire angle up into two congruent parts. So I get angle ABD and CBD as congruent because, or by the definition of an angle bisector. Lastly, because this is the same line, right here, you can say by using the reflexive property that statement BD is congruent to segment BD. And now that you've got an angle, side, angle, you can prove that triangle ABD is congruent to triangle CBD. All right, last one. We've got that BD is the angle bisector of angle ABC. So it's creating congruent angles here. And of ADC, so it's congruent on both ways here. So BD, we got to write this in as our given, is the angle bisector of angle ABC and angle ADC. And that's just our given. Next, using the definition of angle bisector, you can say, and we've already drawn it on our picture, that angles ABC and angle CBD are congruent, but also angle ADB is congruent to angle CDB. And now that we've got two angles congruent out of our three in each of these triangles, that means by the third angles theorem, angle BAD is congruent to angle BCD. We're going to draw our congruency marks on here. And now remember, we're trying to prove it by angle, angle, side. That's where we're going around in this kind of different circular manner. All right, and this last one, because we're doing angle, angle, side, we're using this one right here, this line, and we're saying that it's congruent by the reflexive property. And by that reason, triangle ABD is congruent to triangle CBD by angle, angle, side.